Hello, welcome to my tutorial. Today we are going to discuss the transitive closure of a directed graph. A transitive closure of a graph is constructed to answer the reachability questions and it is stored in the form of a matrix. So if T15 is 1, then we can say that there exists a path from node 1 to node 5. It means that node 5 can be reached from the node 1. The formal definition of transitive closure is given for a directed graph G, which is a set of vertices and edges. The transitive closure of G is a graph G star, which is also a set of vertices and edges. In G star, for every vertex pair VW in V, there is an edge VW in V star if and only if there is a valid path from V to W in G. Now let's try to understand this with the help of an example. Now let's consider the graph shown at the left, which it consists of 5 vertices A, B, C, D, and E, and it has 4 edges. Now let's try to build the transitive closure matrix for this graph. So the transitive closure matrix is also shown here. The first entry is AA. Is there any path from A to A? The answer is no. So the entry is 0. Now A to B. Is there any path from A to B? Yes, there exists a path from A to B because A and B are directly connected by an edge. So the entry is 1. Now A to C. Is there any path from A to C? Yes, there exists a path from A to C and the path is A to B and B to C. So the entry is 1. Now A to D. Is there any path from A to B? Yes, there exists a path from A to D and the path is A to B, B to C and C to D. So the entry is 1. Now A to E. Is there any path from A to E? Yes, there exists a path from A to E and the path is A to B, B to C, C to D and D to E. So the entry is 1. Similarly, we will fill up the transitive closure matrix. Now let's take up another case of node E. So for the last row E, uh, is there any path from E to A? No, the answer is no. So the entry is 0. Is there any path from E to B? No, the answer is no. So the entry is 0. So in fact, there is not a path from E to any of the other node because there is not a single edge originating from E. So all the entries in last row are 0. Okay. The graph shown at the right is a transitive closure graph. It is constructed using the transitive closure matrix. In the graph, we can see that there exists an edge from A to C and A to D also and A to E also. So we can say that node B, C, D and E are reachable from node A. Okay. Similarly, there exists an edge from B to C, B to D also and B to E also. It means that nodes C, D and E are reachable from node B. So now we will discuss the algorithm to find the transitive closure of a particular graph. So the approach behind the algorithm is for to find the path from node U to node B, then one of the following two things should occur. The first is there should exist a direct edge from U to B. Okay, if there exists a direct edge from U to B, then we can say that there is a path from U to B. It's an obvious thing. And if there is not a direct edge from U to B, in that case, there should exist a node W, which is also known as intermediate node, such that there is a path from U to W, and there also exists a path from W to V. Okay. In the second case, W acts as an intermediate vertex, and U and V are the source and destination vertices respectively. Okay, now let's try to understand this with the help of an example. So the graph is shown at the right. Now let's try to find the path from A to E. Okay. To find the path from A to E, first we have to check that there exists a path from there exists a direct edge from A to B? The answer is no. So now we have to find an intermediate vertex. Okay. So let's consider C as an intermediate vertex. Now we have to find the path from A to C. Since there is not a direct edge from A to C, so we have to find the path from A to C first and then C to E. And if there exists a path from A to C and there also exists a path from C to E, then in that case we can say that there exists a path from A to C. So first of all, let's try to find the path from A to C. Okay, there is not a direct edge from A to C. So let's consider B as an intermediate vertex. So as we can see, there is a direct edge between A and B. Okay, so we can say that there exists a path from A to B. And B and C are also connected by an edge. So we can say that there also exists a path from B to C. Okay. So since there exists a path from A to B and B to C also, so we can say that there exists a path from A to C. Okay. We have successfully found the path from A to C. Now let's try to find the path from C to E. Okay. For finding the path from C to E, let's consider D as an intermediate vertex. So C and D are connected by an edge. So we can say that C and there exists a path from C to D. And D and E are also connected by an edge. So we can say that there also exists a path from D to E. Okay. Since there exists a path from C to D and there also exists a path from D to E, we can say that there exists a path from C to E. We have successfully found the path from C to E. Okay. Now we have found the path from A to C and C to E also. So we can say that there also exists a path from A to E. Okay. So finally we can say that there exists a path from A to E because there exists a path from A to C and there also exists a path from C to E. Okay. So now let's try to understand the algorithm of finding the transitive closure. The algorithm is shown at the left hand side. In this algorithm, we are using three variables I, J, and K. I and J are used to for traversing the matrix, and the variable K is used to find the intermediate vertex W. Okay, so in the first two for loops, that is from step number 2 to step number 4. Okay. Step number 2 to 4, we are using two for loops. And if there exists a direct edge from node I to node J, we can say that there exists a path from node I to node J, and we are setting that entry as 1. And in all other cases, the entry will be 0. Okay. Now from step 5 to 11, we are using three for loops. 2 I and J, two for loops we are using for traversal, and the first for loop is used for finding the intermediate vertex W. Okay, if we found the intermediate vertex W, and if there exists a path from I to K and K to J, then we can set that entry to 1. And if we are unable to find such vertex K, then we will leave the entry as it is. It means the entry will be 0. So this is the algorithm for finding the transitive closure. I hope you understand this. So that's all for today. Stay tuned for more updates.